Hi, Algebra 2. Let's talk about Chapter 1, Section 5, which is solving inequalities. Hopefully you've done this before. We're going to be solving one and multi-step inequalities today. One big thing today, which is we can solve inequalities like we solve equations with one additional rule. When solving, if you multiply or divide by a negative number, the inequality symbol must switch directions. Only multiplying, only dividing, only when you are solving. If you see multiplication and division within the inequality, the sign doesn't have to switch. It's only when you, the solver of the inequality, do one of these operations that the sign switches. So just keep that in mind. Here we go. Example 1, we're going straight into a multi-step inequality. Just like an equation. First thing I need to do, and again I'm going to solve, I'm going to graph the solution on a number line and write the solution in interval notation. If you don't know what that is right now, that is okay. We will get there together. So, like I was about to say, first thing we're going to do is get the W's together. I'm going to do that by subtracting the W because I'm a fan of positive numbers. So we have a single W over here, plus 3, is greater than 9. And then my W's all by itself, pretty much isolated, but I need to get rid of that 3. Final answer, W is greater than 6. W is greater than 6. That's how we read that. So let's see how we graph that on a number line. Just going to do a quick sketch over here. Really, the only important number I need is 6. I'm going to do 1 on either side of that just to show some reference, but 6 is the important one, so I just start with that right in the middle. I have a greater than symbol, not a greater than or equal to, so I just have greater than. So I am going to put an open circle at 6. Open circle, meaning 6 cannot be my answer. But anything that's greater than 6 is. So to show anything greater than 6, I am going to shade greater than 6 to the right of 6, draw myself an arrow. All of those answers, so 6.5 is greater than 6, 7 is greater than 6, 100 is greater than 6, everything on the right-hand side. Now, how do I write this in interval notation? What we're going to do is go, it looks kind of like an ordered pair, and we're going to go from the left to the right, and say the leftmost endpoint, and then the rightmost endpoint. So my leftmost endpoint is 6. My rightmost endpoint is all the way at positive infinity. I can go all the way up to positive infinity. Now, we don't just leave it like that. We have to sort of enclose it in something. Because it is greater than 6, but 6 is not a possibility, we're going to put a parenthesis there. 6 is not an answer. Because infinity is more of a concept than an actual number, we're also going to put a parenthesis on that one. So this is our interval notation for this inequality. You'll see there's also a possibility of having a bracket on either side of your interval notation. That happens when you use the or equal to signs, meaning it can be that number. We're going to get to that in example 2, so let's take a look at that. Here we go. More of an interesting inequality here. Again, same direction, solve, graph it on a number line, write the solutions in interval notation. So here we go. First thing I'm going to do is clear out this denominator of 6. Multiplying by 6 on both sides, I get negative 24c is less than or equal to. These 6's cancel, denominator to numerator, since that's 6 over 1. They cancel. I am left with 5c plus 58. Now, my c's are all by themselves over here, but I need to get this 5c over there, so away it goes. So again, right here, subtracting by 5c. That is fine. Nothing has to switch here with the inequality symbol. Not yet. So I have negative 29c is less than or equal to 58. Now here's where we have a switch coming up. I need to divide by negative 29. When I do that, I get my single c all by itself. And I get over here a -2, just like I normally do that math. But now, because it is less than or equal to, but I divided by a negative, I am now going to have greater than or equal to in the middle. So my final answer in inequality form is C is greater than or equal to -2. Graphing that on a number line. I have my number line. Again, my really only important number is -2. I'm going to give you a number on either side just for reference. Greater than or equal to, so I'm going to use a filled in circle here because 2 is an answer, sorry, -2. -2 is an answer possibility. I'm allowed to use -2 as my answer because 2 is greater than or equal to -2. Okay, greater than, again, I am going to shade greater above to the right. There we have it. Now, in interval notation, again, my leftmost endpoint is -2. My rightmost endpoint is positive infinity. Infinity, like I said, is more of a concept than an actual number, more than an actual location. So I'm going to give a parenthesis on that one. But because -2 is a possibility, I am allowed to use -2 as an answer. I am going to give that a bracket. So now you see it's not just looking like an ordered pair all the time. It does look kind of funky with the two different grouping symbols, but that's what we say. So either of these is a good way to say the answer to this original inequality. There we go. Let's now talk about a word problem. Talking about a word problem. This is written on your paper too. Rosa's cell phone plan costs her $50 per month plus 25 cents for each minute she goes beyond her free minutes. How many minutes can she go beyond her free minutes and still pay less than a total of $70? So I need to declare a variable for this to write this inequality. Because she can pay less than 70, that's fine, but she doesn't want to go over 70. Does not want to go over 70, less than a total of 70 is key. So I'm going to say how many minutes? How many minutes? I'm going to let M be my variable. This is the number of minutes that we are talking about here. So $50 per month. So that is a flat fee there, flat fee all the time. Every month, flat fee of 50, plus, it tells us what operation, how kind of them, plus 25 cents for each minute she goes beyond. Hopefully you remember from elementary school, middle school, when it says for each, that is a clear sign that we are multiplying here. So I'm going to take my 25 cents for each minute. That is going to be her total cost for the month. And depending on how many minutes, this cost can change. So, cost for the whole month. I want this whole cost to be less than a total of $70. There we go, less than $70. Then I'm going to solve this and see how many minutes she's allowed to talk. So here we go. I am going to subtract 50 off to the other side. I get 0.25, my 25 cents. All I did was subtract 50, so I'm going to keep my less than symbol, 20. Now, once again, I don't have a calculator with me, so what I'm going to do is change this 0.25 into a fraction, just for the sake of doing this multiplication, as opposed to dividing by 0.25. I'm going to just change this into 1/4 m is less than 20. So now it's easy that I see that I need to multiply by 4 to cancel that denominator. I am left with the minutes. My m value is less than 80. So as long as Rosa does not talk more than, or as long as she talks less than 80 minutes. So she cannot talk 80 minutes. That would put her over her $70 total. But as long as she talks less than 80 minutes per month, she will be good to go. She will stay within her set budget of $70 and life will be good. So there you go, a couple examples about solving inequalities with word problems, with regular examples. Don't forget, flip that switch whenever you are multiplying or dividing by a negative number.